Okay, guys, so the first thing you see at the top of our notes for today is graphing. No, this is not a graphing unit. It's a very small part of it. It's just to help you understand where inverses come from, specific parts of the inverse. So guys, first thing we're going to do is graph our parent graph for sine. Do you guys remember how to graph sine? What are my tick marks labeled? Pi over 2, yep. Good. Excellent. Okay, and I can label negatives. Is it too early, guys? Did everyone have a good Monday off? Yeah, okay. All right, guys, then sine. Is that the one that starts at 0 or starts at 1? 0, good. Copiers are kind of dying. Thank you. All right, guys. So now we're going to graph the inverse of sine. Do you remember what inverses are from Algebra 2? Flip what? Like, yes, I...
So, don't know how to say it in the word. You take the first number and the second number in the parentheses.
The ordered pair, yes.
And you switch them.
Yes, so you're switching x and y.
Yeah, that.
That, yes. Yes, flip those things, yes. So, what that means as far as my graph... That was good for like a Tuesday morning after a long weekend. I'm very proud of you. All right, so think about our labels. What was labeled on my x-axis? Where do you think I'm going to put those now? On the y-axis, yeah. So this is going to be the pi over 2. We're just switching the x and the y. And you kind of have to squeeze it in there. There's not a lot of room. And I know I'm writing really small, so sorry. And so then now the x-axis is only going to go 1 and -1. So we're going to switch around our ordered pairs now for graphing. So sine started at 0, 0. If I switch 0 and 0, it's still just 0, 0, right? Everybody gets that? Okay, so we still have that dot. This point right here, that would be the ordered pair pi over 2, 1. I'll write that one for you. So if I switch it, what is it going to be? So guys, instead of pi over 2, 1, what will it be? Yeah, 1 pi over 2. So we're going to go over 1, up pi over 2, dot. Okay, the next one on my sine graph would be pi 0. So where am I going to go? 0 pi, right? So over 0 up pi. Next would be 3 pi over 2 negative 1. So I'm going to go negative 1 up 3 pi over 2. And then the last one, 2 pi 0. So I'm going to go 0, 2 pi. Could you guys keep following that pattern down below? Okay. And then I'm going to draw it. You guys okay over there? I'm a little worried about it. All right, guys, so that is the graph of the inverse. Is that a function right now? Does that pass the vertical line test? That thing I drew over there? No, if I drew a vertical line, it's going to cross it over and over and over and over. What we have to do with the inverses is look at a very specific part of the graph so that it is a function. So if I only look at that part, magic. All right, do you guys see that that is a function? And do you see how it still covers everything from -1 to 1, like I'm not leaving out anything? Okay, so what did I pick, like from what y value to what y value? Can you see it? What is it? Yeah, it's this. It's from -pi over 2 to pi over 2. Like that's my little window. So that's what we're going to fill into the blanks here. -pi over 2 to pi over 2. All right, and we're going to change, this isn't going to say the restricted graph looks like this. We're going to think about what this means on the unit circle. So you've got this little grid here. I'm going to go ahead and put a circle on mine. Maybe I am. So where is -pi over 2 on my unit circle? All those trig values, guys, they still matter. Where? Yeah, so down at the bottom, like everybody understand that's -pi over 2? Where's +pi over 2? The top, right? Yeah, okay. So from -pi over 2 to pi over 2, that is this right side of the circle. This is what I'm looking at now. Now I know you know what these are in terms of radians, but I'm going to go ahead and label everything over here. So the first tick mark in the first quadrant would be pi over 6, pi over 4, pi over 3, 0. What do you think is happening in the fourth quadrant? Like I'm not going to call that 11 pi over 6. What am I going to call it? Yeah, -pi over 6. We're just going backwards. And then -pi over 4, -pi over 3. So when you answer questions about an inverse sign, those are the only options you have for answers. -pi over 2, -pi over 3, -pi over 4, all of those. That's it. You should never tell me like 2 pi over 3 or 5 pi over 6. It has to be within that window. And again, that all comes from this graph. Okay, because those are the only values in that little box we looked at up there.
So is 0 also an option?
0 is also an option. Yep. Yes. Okay. As far as the graphing goes, guys, I'm not going to ask you to like graph every inverse function. There will be no period change, shifting, stretching, anything like that. I'll ask you maybe 1 or 2 multiple choice questions of like, this is the inverse graph of which function. And that would be it. So it's just like a matching type thing, okay? There's no like real graphing from here on out. Okay, so let's actually answer some inverse questions. So the first one here, it says inverse sine of 1/2. So what we have to think about, based on only the red part of the circle here, I want to know, when does sine equal 1/2? Okay, it's positive 1/2. So is that going to be these first quadrant choices or the fourth quadrant? First, so you've narrowed it down. These are your only answer choices. Which one of those has a y value, because it's sine, a y value of 1/2? I heard it mumbled back there, pi over 6. Yes, okay, that's your answer. You're done with letter E. All right, so let's try B. Inverse sine negative root 2 over 2. Okay, it's negative, so that helps me go to the fourth quadrant. Where in the fourth quadrant would it be negative root 2 over 2? Negative pi over 4, yes. Okay. Letter C, where is it going to equal positive root 3 over 2? Pi over 3, good. Where is it going to equal 0? Where's the y value 0? At 0, yeah. If it was cosine, it would have been pi over 2. You're right. So this is 0. Go as far as you can. If it simplifies to something nice, great. If it doesn't, then just stop. All right, so are we okay with those 4? It's actually easier than the trig values because there's only one answer for these. Okay, you don't have to think about multiple answers. All right, the next little part here, explain why inverse sine of the sine of pi over 6 equals pi over 6. Inverse sine of the sine of 5 pi over 6, like this does not equal 5 pi over 6. Guys, that all comes from, is 5 pi over 6 in the restricted window that we looked at? No, like was 5 pi over 6 one of the answer choices in red here? No, so there's no way that that's going to be true. We'll go into more depth with that later, but for right now, it's not one of our possible answers, so there's no way that can be true. Okay? All right, turn the page for me. Okay, you're going to graph cosine for me. And then once you have cosine graphed, see if you can graph the inverse of it. I'm going to put cosine up just to make sure everybody's on the right track with that. I'll give you a minute to think about the inverse, talk to each other. Okay, guys, so when I graph the inverse, are we okay with that graph? We need a minute. See a few people still writing. Give me a second here to get caught up. Start thinking about what window we're going to use for this one. So let's look at it. Should I do the same window I did last time? Should I do negative pi over 2 to pi over 2? Is that a little function over there? No, not going to work. So, thoughts? What should I pick? I heard 0 to pi. Let's look at that. Maybe. Do that. Does that work? That looks like a function? Yeah. So we're going to pick 0 to pi this time. So I'm going to squeeze in a little graph right over here. So we can think about our unit circle again. All right, so 0 to pi. That sounds less complicated, right? I know 0 is over on the right. I know pi is over here. I only want the top part of the circle, okay? So normal labels. This is pi over 6, pi over 4, pi over 3, pi over 2, then 2 pi over 3, 3 pi over 4, 5 pi over 6. So those are your only choices when we're looking at cosine. I guess hopefully it makes sense if you think about it. In the first quadrant, cosine's positive. What happens in the second quadrant? Cosine's negative, right? Okay, because it's your x values. That's why we're picking first and second quadrant values, because we need to make sure we've got positive and negative options. So let's do a couple of these. I'm going to change letter C just so you know. Let's make you negative root 3 over 2. All right, so part A here, inverse cosine 1/2. Again, top half of the circle, that's your only choice. We completely ignore these two quadrants. No answers from there. So where does cosine equal positive 1/2? What did, pi over 3? Yes, pi over 3. Greg, what do you need to see? I did write negative root 3 over 2. It's really small, sorry. All right, letter B then, inverse cosine of 0. So where is cosine equal to 0? Pi over 2, good. Okay, remember cosine's the x value. Inverse cosine negative root 3 over 2. All right, it's negative, so I know I can only look in that second quadrant. Where is it negative root 3 over 2? Five pi over 6, good. All right, and negative root 2 over 2? Good, 3 pi over 4. Okay, questions so far? It's all back to just knowing those unit circle values and understanding which part of the circle we're looking at, okay? So we've dealt with sine and cosine. That leaves us with tangent, cotangent, secant, and cosecant still to think about. We're not going to graph all of those. Let's graph tangent, but it'll be our last one. We'll graph this one together just to make sure you guys remember. Remember, we would only graph it out to pi. So pi over 4, pi over 2, 3 pi over 4. Negative 1. Tangent's the one that starts at 0, 0. 1, negative 1. Asymptotes. All right, guys, so let's think about the inverse. So again, I'm switching my labels. I realize I'm writing these so small no one can read them, but there you go, they're labeled. All right, so 0, 0 is still going to be 0, 0. Then we have pi over 4 is normally 1, so I'm going to go 1 pi over 4. What about that asymptote? It was a vertical asymptote. What's going to happen to it now? Yeah, it's going to be horizontal, so at pi over 2. So I'm just going to keep following my pattern here. So guys, take a wild guess. Which part of this graph am I going to care about? Bless you. The only part I want is that middle stuff, okay? So you're going from asymptote to asymptote here. So from negative pi over 2 to pi over 2. The asymptotes help you with tangent and cotangent. So guys, we're back to the part of the circle that we used for sine. So draw it one more time just to make sure. So I'm going from negative pi over 2 to pi over 2. The right side of that circle, so ignore the left side over here. All right, and I'm going to change letter B. The tangent of 136 exists, but that's clearly not something you know. Let's make that the tangent of inverse tangent . Oh, we'll go negative root 3 over 3. There's only so many things I can ask you guys, so. All right, so let's answer these. So first one, inverse tangent of 1. So again, only look at the right half of the circle. Where does tangent equal positive 1? Pi over 4, good. All right, where does tangent equal negative root 3 over 3? It's the root 3 over 3, so I know that's an over 6. Is it going to be the positive over 6 or the negative over 6? Negative, so negative pi over 6. So what do you think that makes the answer to C? Positive pi over 6, good. And then the last one, where does tangent equal negative root 3? Negative pi over 3. What do you think? Are these almost easier than the original trig values? Yeah, not bad? Okay. All right. Let's talk about, we're not going to go through, okay. Somewhere, I know I've drawn a whole bunch of circles for you already today, but we're going to just draw 2 more. So the first one here, I'm going from negative pi over 2 to positive pi over 2. So I want the right side, ignoring the left side. The second one, we'll draw it from 0 to pi. We just want to figure out which functions go with which part of the circle. Okay, we know inverse sine goes with the first one. We know inverse cosine goes with the second one. And we figured out inverse tangent goes with the first one. All right, so that leaves me with cosecant, secant, and cotangent. So let's start with cosecant. What is cosecant related to? To sine. So which part of the circle do you think it's going to go with? Yeah, this guy. Okay, so this is where inverse cosecant goes. All right, that leaves me with secant next. Where do you think that's going to go? Yep, over there. Okay, so cotangent, yes, it's related to tangent, but where do you actually think it's going to go? Yeah, we got to keep it balanced, right? 3 on each. And guys, that comes from the asymptotes with cotangent are at 0 and pi, so it makes more sense for it to go with that part of the circle. So does the third quadrant ever get used? Nope. No love for the third quadrant. It gets ignored. Okay? So again, these are your only answers from negative pi over 2 to pi over 2, from 0 to pi. That's all we can think about. Okay? The next page in your notes, it's got the graph for all of them. So we did those first 3. Then the next 3 graphs, that's inverse cosecant, inverse secant, and inverse cotangent. Do you guys see how they have an arc written in front of them? Those mean the same thing. So like arc sine is the same as inverse sine. It's just notation, but you're going to do the exact same thing with it, okay? All right, let's practice a few of these. So if you turn the page, I want you to start with 1 through 9. I'll give you a little bit of time here. 7, 8, and 9 look a little different, but they're really not too bad. Try these. Work with the people at your table. Look at your circles. Which part of the circle do you use? If you guys still don't know your circle values, please, please, please learn them. And then remember them, right? I know. So guys, I'll give you some time here. I'll be walking around. If you're stuck on anything, let me know. Okay, so cosecant, what is cosecant? Yes, so what I do, I already have this cosecant, so I write it. Just do that. Okay. Way easier. Yes. Yeah, it is. Okay. Right. Oh no, no. Okay, yeah. Okay. So do this as if it's cosine. So what is that? Okay, but cosine doesn't go into the formula. 3 pi over 4, yes. Yes. It's okay. We're going to make it through this, guys. I promise. Runny noses and all, we'll get there. Guys, let me give you something that I think will make the secant and cosecant ones easier. So if I flip 1/2, what do I get? 2, right? So if I see like inverse cosecant of 2, I'm going to do that as inverse sine of 1/2. Okay, because I don't like thinking about cosecant. The other ones are obviously a little trickier to flip. What is root 3 over 2 when I flip it? 2 root 3 over 3, and then root 2 over 2 is just root 2. Okay, so like I think there was one that was like inverse secant of negative root 2. I don't want to do secant. So I'm going to do inverse cosine of negative root 2 over 2. So I don't have to think about that one. Okay? So I'll give you a couple more minutes. I think that's like numbers 4, 5, and 6 right in the middle there. Yep. So try those for a second, then we'll go through these, I promise. Ooh, did you guys see we're actually in a winter storm warning now? I agree. That's key, yeah. Yes, from 1 a.m. tonight until 7 p.m. tomorrow night is the winter storm warning. So it's like they're saying 4 to 6 inches of snow and then ice accumulation on top of that.
So they like when I was driving, they like salted half of the road, and I was like, I might need to salt the whole road.
Maybe. Might help. Yeah.
Yeah, it's a great idea. Just get washed up and then freeze and
Which we're letting no one really too upset about. All right, guys, let's go through these first 9, and then let's see how we're doing. All right, guys, first one, arc cosine root 2 over 2. Everybody, what'd you get? Was that really everybody? That was kind of sad. That is pi over 4. Number 2, arc sine negative root 2 over 2. Good, negative pi over 4. Arctan of root 3. Pi over 3. So guys, remember, for tangent, the root 3 over 3 comes from something over 6. Just the root 3 comes from something over 3. Okay? You need 2 3's to add to your 6. Right? That's not at all mathematically how that works, but that's how you can remember that, okay? All right, so 1, 2, and 3 we get. That's not terrible. Okay. 4, 5, and 6. This is where I was talking about. Think of it not as cosecant or secant. So this is really inverse sine of 1/2, because I don't want to do that problem. So what'd you guys get for this? Yes, let's whisper. Pi over 6. Good job, guys. Pi over 6. All right, the next one. Inverse cosine. I'm going to think of negative root 2 over 2, because I don't want to do secant. So where does that happen? Excuse me. 3 pi over 4. Did anybody say negative pi over 4? Yeah, okay, remember that's the wrong part of the circle. Cosine is the top. All right, now cotangent, I would not switch and think of tangent just because they use different parts of the circle. So with this, you're just thinking, where from 0 to pi does cotangent equal negative 1? Well, I know that's not going to happen in the first quadrant, so somewhere in the second quadrant. What do you think? What else? We'll just say it. It's okay if you're not. Okay, right idea, wrong place. Negative pi over 4 is down here. So you're right that it's the over 4. What would that be in the second quadrant? Yeah, there you go. So if it had been inverse tangent of negative 1, that would have been negative pi over 4. Okay? All right. All right, how'd you feel about 7, 8, and 9? Did you understand what I was asking you to do, or did they just look weird? Didn't know? Okay. They do look a little weird. We're going to start on the inside. So I'm going to leave the cosine out here. What is arcsine of 1/2? Good, pi over 6. Then, what is the cosine of pi over 6? Root 3 over 2 is your answer. Does that make sense? Okay. All right, next one here. Inverse cosine negative root 3 over 2. So we're going to start on the inside there. What do we get for that? Good. 5 pi over 6. And then what's the cosine of 5 pi over 6? You're kind of just running in a big circle here. It's negative root 3 over 2. So you're back to what you started with. All right, then tangent arcsine of 0. So where does sine equal 0? 0. And what is the tangent of 0? 0. Yes, lots of zeros happening. There we go. All right. So far, so good. We're almost done, guys. Let's look at the next section here. Okay. We have different numbers now, right? Do we know what 3/5 is on our circle? No. So we have to draw a triangle for these. Okay. All right. We are using this inside part to find an angle. Guys, every time you do inverse or arc, whatever, you are finding an angle. Okay, like the pi over 6s, pi over 4s, those are angles. So what we're doing here is finding an angle. It's just finding it means drawing it appropriately on a triangle and labeling it. So we're starting on the inside. Arc cosine 3/5. All right, it's cosine, so I know I can't pick down here. So first or second quadrant, where am I drawing this? First. Okay. Theta, right angle. Cosine's 3 over 5, so what does that mean? Yep, adjacent, so down here is 3. Hypotenuse is 5. Could you label the other side? Yes, 4. Okay? That is the entire purpose of what's on the inside. It's just to give you the triangle labeled, because you now have your theta. Can I now find the sine of theta? What do you see, Molly?
I was just figuring out where you got it.
Oh, okay, yeah, it's representing an angle. So what do you think? What's the sine of theta going to be? 4 over 5, good. And that's your answer. That's it. No. Well, because the sides are different. Like, look at 12. Your numbers are 2 and 3. That's not a 3, 4, 5 triangle. And 11 is actually weird, because if we'll try to draw it just for practice, but you don't have to. Let's think about it. Are we okay with it would be in the first quadrant? Okay. Adjacent is 3. Hypotenuse is 4. So is that a 3, 4, 5 triangle? No. I could find the other side with the Pythagorean theorem. But based on what this question is asking me, do I even need to do that? No, I am just asking you the secant of this angle. 4 over 3, yeah. Okay? All right, now the last one. Number 12 here. Where am I drawing my triangle this time? It's sine, so I can't be over here. What do you think? Still first, okay? I promise you're not always going to draw them in the first quadrant, but this one is. All right, sine is 2 over 3, so that means opposite is 2, hypotenuse is 3. What does that make the other side of my triangle? Square root of something. Excellent start, yes. Square root of 5, good. Was anyone thinking square root of 13? Okay, that would be if I was looking for the hypotenuse. But since I'm looking for the leg, you actually subtract. Do you see it? Okay. So what is the tangent of my angle now? 2 over root 5, and if I rationalize that, I'd get 2 root 5 over 5, okay? All right, we're actually going to skip this last row. 13's fine, 14 and 15 are pretty tricky, so we're not going to think about them right now. Okay, so that's the end of your notes. How do we feel? Yeah. You shouldn't need to draw a triangle for 7, 8, and 9 because those are values from your unit circle. You could, like if you get stuck, you can certainly think of it that way. But like for 10, 11, and 12, that's your only option, okay? Other questions, guys? All right, let's do some whiteboard problems. So go ahead and find your whiteboard somewhere in your desk. Yeah. Just add it all to that pile of yellow paper. Thank you. All right, guys, first one's up here. When you're ready, hold it up for me. There should be enough whiteboards for everyone. The whiteboards? Do you want to go check in the desks in the hallway? I know that's weird, but... yeah, they should be there. Guys, double check if your desk has extra whiteboards, get them out. Yeah. I feel like there's some back there in a bin. Thank you. Yes, good. Found some? Okay. They're hoarding them out in the hallway. All right, guys, hold it up. Yeah. No, because it's cosine. Yes, yes. If it was sine, like you're using the wrong part of the triangle. Yeah. Yes. Like top of the circle. Yes. No. Look at that one again. Yes. 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 No. Yes. 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 Good. Nope. So when you do the top of the circle, it's just your normal tick marks all the way around the pie. So like that's just being in the second quadrant makes x negative. Okay, but these are like 2 pi over 3 and 3 pi over 4. They're not negative angles.
Oh, because they're radians. Get it?
No, so okay, let's go way back here to when we graphed the inverse cosine. If you look at like the part of it we picked, did we pick negative values? No. But with sine, we did, right? Okay, that's why you can get negative answers for sine and you won't with cosine. Okay? All right, guys, back to it. First one, answer was 5 pi over 6. Okay. All right, let's try again. Let's do cosine negative 1. Yes. I feel feel like this is not going to fly well. Ooh, okay. No. No. Yes. No. No, no. Yes. Yes. Tom, let me see yours, sorry. No. Look at that again. Yes. Yes. No. Yes. Oh, sorry, Mackenzie. Okay. Yes. Just holding it up. Can you read that? Let me see, Katie. No. Yes. 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 All right, guys, think about it. Cosine 0 there. So you're on the right track. Yes. Does that say pi? Oh my goodness, yes. There's no E. I'm not eating pi. The answer is pi, guys. A lot of you told me 3 pi over 4. That's where tangent is equal, or cotangent is equal to -1. But cosine, remember, is the x value, so over there at pi is where it would equal -1, okay? All right, let's try again. Let's do... inverse sine -√3/2. No. Close. Yes. Yes, I know you're like sneaking it up. Like... Yes. Good, 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 good. No. Check with Josh. His was right. Good, 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 good. Doing well, guys. Yes. Do you get it? Okay. All right, guys. That one was -pi/3. Okay, let's try again. Let's do inverse tangent -1. No. 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 I think yes. No. Yes. 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 Yeah, you were good. Yes. Yes. No. Yes. Think about which part of the circle tangent comes from, okay? Yeah. Yes. Good. Good. Guys, remember, tangent is like sine. It's this part of the circle. Good. A lot of you were telling me 3 pi over 4. Okay? No, not for tangent. That's no good. So the answer was -pi over 4. Okay? All right, let's do another one. Let's do inverse cosecant √2. Yes. No. Yes. 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 Yeah, do you get why as well? Okay. Yes. Don't let the little -1 of cosecant make you think negative. Good. 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 Yes. All right, guys. That one was positive pi over 4. Okay, remember, think of it as inverse sine of root 2 over 2. It's just easier. Let's do inverse secant of -1. I'm sorry. -2 root 3 over 3. Don't be scared. Yes. You're on a roll. Nope. Yes. Yes. No. Because it's -2 root 3 over 3. No, no, yes. No. It's secant's related to cosine, so it's got to be pieces. Yes. Doing well, right? Okay. Yes, 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 yes. Okay, good. A roll. Yes. All right, guys, that one ends up being 5 pi over 6. Okay. All right, let's shift gears a little. Let's do cosine of inverse sine of -5 over 13. Just for fun. Good. Sorry, there was a weird glare. No. I think you gave me cotangent. Yes. No. Draw a triangle. Okay. Good. 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 Where does the triangle go, guys? What quadrant? 4. Start there. Nope. Give you a minute, guys. Keep trying. Yes. Good. As always, it's so important that you draw your triangle right. Yes. No, if you write cosine of 12 over 13, you would be wrong. You just write, yeah, just the number. Because if you're taking cosine of something, good. It's cosine of an angle. You're not taking Yeah. 12 over 13 isn't your angle.
Yeah.
Okay. All right, guys, let's go through this one, and then I'll give you another one of these. All right, so inverse sine. So I know I can't be over there. Is everybody okay with the triangle should be in the fourth quadrant? Okay. Opposite would be -5. Hypotenuse is 13. Guys, is the hypotenuse ever negative? Okay. That side's 12 then, right? Common right triangle, Pythagorean triple, all that stuff. So now I'm just asking you the cosine of theta, which is adjacent over hypotenuse, and you're done. Okay. Don't make them harder than they are. In third, are any of these ever in the third quadrant? No, think about the parts of the circle we use. We use the right side, or we use the top. Poor third quadrant is neglected on both occasions, okay? So, yeah. It's the raw end of the deal. Okay, let's try another one of those. Let's see. Let's do secant of inverse cotangent of negative. Okay, we won't make it too bad. 3 over 4. Can't make it so I can do it in my head. And I wrote that in a way where you have to think about what's actually negative. Is it the 3 or the 4? Because it's not both of them. Step 1, triangle in the right quadrant. Okay, you got to figure that out first. If you need to, go back and double check. Where is cotangent? Yes. Yes. Good work, guys. Yes. Good job. So close. You drew your triangle in the wrong quadrant. Yes, but look back at why that's wrong. See if you can figure that out. Yes. No. Not quite. Couple mistakes there. Maria, Kate, troubles? Okay, your triangle's in the wrong quadrant. You have things like flipped around? Yes. Yes, good. Do you get why it would be in that one, Leslie?
Yes. I think it's just because I got confused.
Which one? Yes, so that's the tricky part here. It changes which quadrants you're in, so don't just leave tangent and cotangent alone. No, no. We're dealing with secant. There's got to be a hypotenuse in there somewhere, right? Starts dealing with cotangent, and then you switch over to secant. Yes. Yes. That makes sense now. Okay. All right, guys, let's go through it just to make sure we're all okay. So we start on the inside with inverse cotangent. Remember, inverse cotangent is the top of the circle, so we cannot draw it down there. It should be a second quadrant triangle. Adjacent over opposite. So the negative goes with the 3. And then the hypotenuse we know is 5. Are we okay with the triangle setup? Okay. Then I just need to do secant of that angle. I know that's just cosine flipped. So instead of negative 3 over 5, it's going to be 5 over negative 3. And then you're done. Okay. All right, are we okay, guys? Okay. Homework. I'm going to give you the last 10 minutes here to work. So you have a classwork worksheet and a homework worksheet. It's just one's the front and one's the back. So on classwork 6.1, I want you to do the middle column. And then from homework 6.1, which is the back, let's do the first column. Everyone knows that columns go up and down, right? Okay. Making sure we don't mix them up with rows. Okay, guys, use your time.